there's a lot of information on this slide, but let's try to condense it down to the key points and start just by looking at the ring flip conformations here. So we have on carbon 1 this methyl group, and we know that when we do the ring flip and we get the ring flip conformation, axial substituents become equatorials, equatorials become axials. So this methyl group goes from axial to equatorial on that same carbon during the ring flip. In terms of energy, there's this interaction known as 1,3 diaxial interactions. So if we set this reference carbon here as number 1, and then number out 2 and 3, and then in the other direction 2 and 3, what we find is that we also have axial and equatorial hydrogen on the carbons 3 atoms away from number 1. And the issue becomes this methyl group is quite large, especially if you were to draw it out or build a model, and it starts bumping into these axial hydrogen. We have this through space interaction here, and this is known as steric strain. Steric strain is a very broad term. This specific type of steric strain is called a 1,3 diaxial interaction. So an axial group on 1 bumping into axial substituents at carbon 3. When you do the ring flip and put this large methyl group equatorial, that relieves those 1,3 diaxial interactions, making this a more stable conformation. More stable, lower in energy. Those two things go hand in hand. So the sum of this is that we want our large groups to be equatorial if possible. And because cyclohexanes can undergo these ring flips, what's going to happen, the majority of the molecules will exist in the more stable form. These values can be quantified by what's known as the A value. And that's just a way to quantify the amount of energy it costs for a molecule to have a group in the axial orientation. So as you can see, here's some different substituents. Here we have the halides, a hydroxide, methyl, isopropyl, and tert-butyl. As the group gets larger, the A value gets larger. That means methyl isn't very happy being axial. But if you go to an even larger group like isopropyl or tert-butyl, those are even less stable in the axial position than the methyl group. So if the molecule has to make a choice and it can't put all of the substituents equatorial, it will put the largest substituents equatorial. And we'll see that when we go through some examples.